everybody who is joining and is taking the time out of their day to learn about FunForm and what we are doing. So FunForm is working on making building envelope retrofits simple. We all know a lot of the reasons they're not. We won't need to go into them. We also know the reasons why they're very important. We are a vertically integrated envelope retrofit solution provider, working to deliver projects easily, quickly, and on budget by simplifying the decision change, reducing redundant communications, and streamlining data collection, design, fabrication, and install. So we are a technology-enabled design build firm with prefabrication. What that does, and a lot of what our work has been doing, is around developing enabling technologies that allow these processes to happen much faster, much more efficiently, and to overlap the processes. So where a typical envelope retrofit would take between 24 and 33 months between design, planning, finance, and install, our process will be between 6 and 11 months. The enabling technologies that we're using are both financial and legal and insurance, and also software and hardware. So here we're looking to reduce and align the project team. We've seen this be a problem over and over again by taking all of the contracts on a typical project and reducing that to a simple three-party contract between FunForm, the owner, and the GC. What we're doing different, we flipped the script. We're starting with the bid. What we've learned in researching and looking at a lot of case studies and a lot of projects is we were looking for the sameness across all of the projects, not the differences. And what we found is that all of the projects could be broken down into layers, and that we could identify the solutions prior to even going into the design phase. So the software that we're developing goes from the scan to the project model to the decision software to the build solution, and then the work package. So we're able to identify all of the penetrations, all of the repairs, anything that's needed on that envelope to price it before we even go to the exterior. And our process is a system solution. So because I love alliteration, we're at function, form, fabricate, field, feedback, and find. We start with find, however. We're not going to be a solution for everyone. We're not trying to get on every single building in New York City. We have at the beginning of our process a find solution. It's a go, no go. That's where we're looking at whether the building can be both financially and physically successful with a building envelope retrofit. Our function, we've standardized our data collection. We found that there was a lot of overlapping data and organizing the data on the building to actually be usable. So we've standardized the data not just with the scan, but with the physical inspection, the structural inspection, and the we're using the energy benchmarking, HERS. We've got a lot of different pieces that we've pulled from to standardize the data and collect the data that's actually meaningful to the project and can be fed into our system. The next thing we do is from that scan, we're not modeling the entire building, we're modeling every system of the building. And then we have decision software that breaks down the solutions for each of those systems. So again, there's a finite number of solutions for our building typologies in New York. We don't need teams looking at the solutions and coming up with novel ways to solve for things. We need to be able to deploy to have standardized packages of both products and bid packages. So as all of that's going on, the exterior design is finalized. We're flipping this model. We're doing design build at the front, and the design or the envelope, the actual colors, shapes, textures of the envelope comes either concurrently or after we've already figured that out. We're not doing a big design, going through a lot of design, bid, rebid, because we're able to come up with pretty much the number right at the very beginning. Fabricate. So we've developed a solution that allows us to fabricate our insulation panels near site, on site, or off site. We're also able to coordinate with the control of the site. So as you're controlling a job, We're calling the site our flexible factory. We're wanting to control the way the material and crews move on the site and not have anybody held up. So it's 30% of the time that people are actually doing their job on site. The other 70% is they're waiting for someone else to finish, waiting for material. It just leads to a lot of frustration on site. So we've tried to figure out solutions that allow us to be flexible in our install, flexible, and let the crews have a lot of control. If one crew is producing quickly, then we're able to adjust the output for that crew. The other thing that we can do from that mapping, from our scan, we're able to track the product all the way from manufacture through the install in the building. And the scan in our software map all of the raw material to reduce the seams and use the largest panels possible to reduce the time on scaffold. And contractor acceptance. My main joke is, as a contractor for 20 years, anytime I would try something new, I would always get pushback for about the first 3 times. And that was, why is she doing this? She's going to do it again. Oh yeah, this is better. So the whole system has been designed around getting that contractor acceptance very early, removing takeoff, bidding, and procurement time, and also providing a technology opportunity to upskill the crews, while not really making a lot of variations from existing installation methods. And then feedback. The same scan and data capture technology we use at the beginning of the project, we use at the end of the project. But we're also adding in production time, what went well, what didn't, how the products performed, what the crew feedback is. So it's quality control, production time, and all of that allows us to provide that next piece of it, which is the energy performance warranty, the facade maintenance warranty, and the maintenance contract on the project. So fabricate. We are using EIFS, or exterior insulated finish systems. Lots of people have lots of opinions about it. I love it when it's used in the correct context and when it's done well. It's a known, tested, and code accepted solution. There's an existing workforce. It's reasonably priced, long lasting, and there's design flexibility. So each one of these are the things that we felt were needed to be able to provide a scalable solution for envelope retrofits, as well as to be able to bring a price down. We didn't want to start with something that was super expensive and then try and compress the price. Much easier to find a solution that's been in the market 60 plus years and understand where it's not efficient, where the supply chain and the value chains have not been innovated in. Design flexibility is another thing that's really important. We're not tied into a single system. We have a lot of opportunity, color blocking, carved pieces, applied elements. All of these can be added. So you're adding a huge amount of design flexibility for the exterior designers to really have an impact across buildings and personalize the properties. We studied over 20 projects that had undergone EIFS Overclads in New York. Here's a few of them. We both visited projects and met with owners, met with contractors, mapped all of the supply and value chains, met with all of the material manufacturers. So these projects are being done in the wild, and they're being done obviously on budgets that these owners can afford to do them. We did not hear one bad response. In fact, one of the things I loved is one of the owners' teams called these exterior modernizations, which I thought was a really great term. So what are we doing different from the existing systems? So EIFS does have problems, any solution does, but we're solving for all of the known points of failure. Those are at windows, doors, corners, and reducing fabrication time. So we all see these buildings in New York. If you look at the picture around the windows, the corners, those are the failure points. That's air and water intrusion. They account for 1% of the facade, but 90% of air and water intrusion. Also, all of the details when you're looking at window installation and the flashing solutions are all very installer dependent. We've worked to remove that. Time intensive. So we've also focused on the piece of the install that takes the most amount of time, and that's adhering small 2x4 boards to the facade. So each board is pushed up against the building and shaped, and then adhesive is put on, and it's put on the building as many times as it needs. That's the thing that in all of the research that we did takes the longest, both the window flashing and the EPS board installation. So those are the things that we focused on solving for. We've developed a set of products, starting with the foam. We're using Neoport GPS in large format sizes. So where you typically have a 2x4 panel, we start with 4x8 and move up. We can go up to a 4x12 board. We have our Fun Fastener. These are fasteners that we're working with the fabricator that's already had these proven and tested in multiple locations in Europe. And then the Fun Frame is our window solution, and Fun Factory is our fabrication. So the foam and the fasteners we won't go into in detail, but I will talk to you about the frame. This is our solution for replacing windows and existing openings. What we have is, go back, is a large piece of, we're funded by NYSERDA currently, and NYSERDA has asked us to look for R30 solutions. And R30 with Neoport is a 6-inch piece of foam. What we've done is put a 6-inch piece of foam, and then we've installed the frame into a foam bed. So our scan allows us to get within millimeters of the actual opening of the existing window. And because we're outboarding the window frame, we don't have to worry about coordinating the removal of the existing window with the install of the new window. So again, that's field flexibility. We wanted to decouple those solutions. The other thing that we have, when we put this in a solid piece, so we're able to scan and manufacture all of these frames at the same point. Our window partner at this point is Alpen, that does high performance windows. They're based in Denver, Colorado. We're working with an innovative window that they'll be launching this fall. Yeah, so we also have, the frame comes in without the window. We've actually got it so that we can then, when the old window is removed, we can install the new window into the frame. And the mesh and drip edges and everything that's needed is already in that Fun Frame. So this allows several things that we're able to do is we're now able to make all of the work on the field flat work. There's no returns, there's no back wrapping. So the mesh that comes off of that comes incorporated, integral into the window cassette, into the frame, also then just joins up with the foam panels as they set them. Then it's a base coat and a top coat. And we've got as close to a barrier system as we think you'll find for EIFS. That does not mean that we're not including drainage. So the Fun Factory, this allows us to, again, as we mentioned, putting the crews in control of the production of the material, just like they are now. The factory can be located on-site, off-site, or near-site. The two foam expanders that are nearest to New York have lots of extra paving areas around them. Lots of opportunities to, if we're doing multiple projects, to set a single factory in a warehouse location in New York as well. And this will just give you a little bit of a taste of what the factory can do. So we bring the boards in already slabbed. We have the ability to shape the face. So this is where we can do carving, rounded corners, any sort of lettering, anything that you want on the face, just providing a bit more design flexibility. So this setup currently has 7 different heads as well as a printer. And we bring up the sides. We have a vacuum panel that picks up the foam boards. Sets it in place. There's a lot of stuff going on at that point where we're leveling and laser marking, so we know all of our boards are flat. And then we're able to shape the panels. So this can be, we can shape them on both the front and the back. So our focus was on being able to fit snugly up against the face of the building. So that scan that we take, we do a deviation analysis to understand anywhere on the panel that needs to be cut out to be able to get a snug fit to the building. Sorry, I had a little freeze. So the advantages that we've worked to develop regarding the enabling technologies of the scan and the software, and then the hardware pieces, were now the data capture and processing. Not only do we have a 3D model for pricing, design, and install, we're able to catalog and specify standardized details. The mapping software, less waste, cleanup time, and the other thing is we're able to slab those boards ahead of time so we can actually keep the waste, and all of the waste is captured at the factory. So we're not actually taking material up, bringing waste down, and moving the waste off to a dumpster. The software for the procurement and logistics. So the software maps as well as outputs the BOM. So every piece of window, foam, fastener, adhesive, caulking that needs to occur is automatically generated from the software. Using these prefabricated large format boards reduces project time install and improves quality because we reduce the number of seams on the building. The fasteners, depending on the adhesive we've chosen or the fastener type we've chosen for the backup wall, those will be integrated into the panels as well. The window cassette, the FunFrame, is what we think is our enabling hardware technology. It allows us to seal that building and remove any opportunity for water intrusion or air intrusion, and it's not installer dependent. So that piece is completely prefabricated with the frame in. It'll also allows us to increase the production time because we can do all of that off-site, bring it to the site, and those just get plugged in. The mobile manufacturing platform reduces costs and handling, and then we have the post-install data capture. So our current timeline, we have gone through prototype. We've won eRobot prize from the DOE. We've been fortunate enough to gather funding from NYSERDA for a feasibility study. Our patents have been applied for. We've received a contract from NREL for our first pilot as part of the Advanced Building Construction initiative from DOE. That pilot is occurring in October of this year, where we'll be doing install. We're currently in design and data capture on that project. We'll then spend over the fall and winter doing our testing and certification of the various pieces of the system. And then we'll be moving on to pilot 2. Those are all secured. So the way we've looked at this, I'm an old developer and had a design build construction firm for 20 years. So we're doing it step by step. We're taking this, we have 2 buildings, this exact type building. They're 4-unit barrack style masonry. These are our first pilots. We're doing a relatively manual process. So this is, we really want to figure out everything, dealing with the sills, dealing with the window openings, dealing with the grade connection, dealing with the soffit overhang connection. So we're running this project relatively manually, but we're still doing the window cassette and the larger panels.
Michele, you have 2 minutes.
Thank you. This is our second pilot. It's steps up. It's a 2-story buildings, exact same buildings. Here we have balconies and sort of lower level entryways. So each thing that we're doing here is we're trying to get as many revs on as many odd details as we can so that we can figure out how to solve for those, and those details will become standardized. Here you see you've got 4 gas meters, we've got the electric meters. All of those will be detailed and figured out how we're going to detail those for future. Here we're looking for our off-Broadway fall 2025 pilot, where we'll be looking to do the fully automated solution. So on our second pilot, we will be having the factory. We'll be arriving on shore in February to deliver that site. So each thing is stepped. We're going from manual, semi-automated. Here for this project, we want to do an automated solution. That means we do our full data capture software to production and install. So we're seeking a building similar to this massing, 3 to 4 story, preferably masonry in a suburban location. And then off-Broadway, spring 2026, we first come into New York. We will have a fully automated solution with regulatory approvals for New York City. This is going to be our typology building that we're seeking to do the most work on. A lot of reasons, but we are looking for a building 6 to 7 stories in an outer borough that has to deal with local law 97 and local law 11 compliance. So if that's a building that's in your portfolio or you know someone, that's our goal for 2026. And then in 2027, after we've proven it out and gotten everybody in New York City comfortable with the solution and the installation, that's when we scale. So thank you for your time and welcome any questions.
Great. Thank you so much, Michele. So
Sure.
if anyone has a question, just unmute yourself and feel free to jump in. Michele, I have a question for you. In
Sure.
terms of the on-site option that you're describing, your on-site factory, how large is the footprint that you're going to need for that? Is it the size of a typical container or construction trailer, or what are you looking at there?
It's about half the size of a 40-yard dumpster. So
Great.
it's going to be less than a 40-yard dumpster, what it typically would be on site.
And then that'll allow you to do the 4x8, or I can't remember if you said 4x12 panels within that?
Right. Yes.
Great. Anyone from the audience have questions? I will ask you one last question then, Michele. In terms of PTAC openings or dealing with the heating and cooling on site and the prevalence of heat pumps coming into the market, what are your thoughts on that with respect to your system and how to incorporate the openings for those?
Those will be in our plans. So all of that, all of the penetration and projections from the building are layered in the software. So those are all dealt with at the very earliest stage.
So in terms
So
of the framing that you have for the window units, are
Yep.
you looking at anything similar, or there would just be an opening to the contiguous to the opening of the building?
No, we have a whole system of penetration panels, which the window cassette is one of. So anything that penetrates the building, utilities, mechanicals, we have developed a solution that will for the penetration of the panel and the air and water sealing.
Great, thank you. Last call for any questions from the audience. All right, Michele, well, thank you so much. Greatly appreciate it. And yeah, the recording will be available if anyone wants it, and we'll also be sending out your slide deck. So thank you so much.